when does it struggle? Okay, if you have high dimensionality, then it uses crazy amounts of memory, right? Why? Because dimensionality means there's a bigger state space, and BFS basically explores the whole state space. That's stupid. If we wanted to make real AI, we've got to solve that. In fact, this is the problem. Of all the problems that there are in AI, visiting all of the state spaces is the only way to guarantee optimality, and yet visiting all of the state spaces for any interesting problem is utterly, utterly, utterly impossible, right? Imagine if just to make a life decision, like, should I go to the bathroom right now or not? Imagine if you had to consider all possible outcomes. Well, if I go to the bathroom, there might be this person in there. And if I see that person, I could run, or I could say hi, or I could punch him in the face. And if that person's not there, then I could use this stall, or I could use that stall. And if you thought through every possibility, you would sit there blocked, being full, and you'd never get to the bathroom, and you would pop first, right? I mean, humans don't consider all possible states, and this isn't even all possible states, it's just all the states necessary to find the goal. Okay, there's the possibility of going to China and back first, and we don't consider that one because why would you go to China if you need to use the bathroom, right? You wouldn't. You just search far enough to get yourself to the bathroom. But even still, it's a crazy number of possibilities to search, and AI doesn't do that. So to improve on breadth first search, we need to figure out how to do it without visiting every possible state. You see that? Okay. Here's another problem. Does it handle moving goals? No? I mean, what if the goal moves into a place it's been before? It'll never go there again. That's a big problem. Does it handle goals that are defined in terms of other players? Can you use breadth first search for chess? No, because moving your queen here is a great idea sometimes, unless you have a good opponent, and then moving your queen there is a better idea, right? Because it depends on what they're doing. That's kind of the same thing as moving goals, right? But you see how breadth first search doesn't solve that? Now, the general principle does, so we need to talk about how to apply it to multiplayer games. Does it handle non-determinism? What is non-determinism? Okay. Determinism means that the consequences are determined by the actions. Okay?
Like a philosophical question?
Yes, and there's a lot of philosophy in AI, and yes, I'm going to take lots of tangents on it. So if you hate philosophy, you're not going to like me. So non-determinism, is it a thing? Yeah.
Are you saying like if you had randomness in the equation?
Yeah, is there randomness? So for example, if you're right here and you say go east, will you always end up in the east state? Well, sometimes, let's say you're drunk. You think you're going east, but you actually go north. Or let's say you go east, but sometimes there's an alligator there and sometimes there's not. Can you see that sometimes the universe isn't consistent? Well, do you see that non-determinism, noise, other players, moving goals are all kind of the same thing?
It's like something quantum computers and quantum states.
Yeah, we could get into parallel universes and there's all kinds of places this could go, and I'm not going to explore them all.
Like qubits and things like that, and checking to see what random state they're actually in, and blah, blah, blah.
Yeah, supposedly quantum computers can check multiple states at the same time simultaneously. Blows my mind. But essentially they do linear algebra where every possible combination of the bits is computed in parallel, something like that. And that would be really awesome. Okay, let me make a point here. Non-determinism is indistinguishable from a hidden variable. Let me identify what I mean by that. Imagine a world in which you're trying to figure out what happens if I do this. and you do your math and you come up with an answer, but there's a variable, something that affects the universe that you don't know about and didn't include in your equation. You can't really perfectly predict the future, right? Okay, what's non-determinism? That's when you can't really perfectly predict the future. So the argument about non-determinism is when there's no way to predict the future, and a hidden variable is you can't predict the future because there's something you don't know. Is it possible to know everything? Well, not practically anyway. Okay, non-determinism only exists if an omniscient being cannot predict the future. And so a lot of people get all twisted up about there must be non-determinism or else we wouldn't have free will. Because if an omniscient being knew what we were going to do, then we wouldn't have free will. And so then people get all philosophically weird about that and say, okay, non-determinism does or doesn't exist, and people have holy wars about it. As far as I'm concerned, I don't really care because non-determinism is indistinguishable from a universe with a hidden variable, and we don't know everything. We'll never know everything. So I just describe things that can't be determined as we don't know everything. And if you don't know everything, you still can't determine everything. And either way, there's noise in the universe. Does that make sense? We know there is noise. We don't know if there's non-determinism, but we can philosophize about it. Yeah.
So does that essentially mean that breadth-first search works on anything abstract or mathematical, but nothing that's realistic or like actually in the world?
Yeah.
Okay, perfect.
Well, okay, think about it this way. Imagine I'm going to search from this position in the room to that position in the room, and on my way over here, the stock market in China changes, the price of tea goes up. I didn't see that coming. That doesn't affect how long it takes me to get over there, right? So this is an example of a hidden variable that doesn't make a darn bit of difference in my life. On the other hand, if I'm trying to go from here to there and the lights go out because a guy was working in the other room and, I don't know, a barrier appears for some reason, then there's a problem.
Really, tracking the price of tea in China, and they're really, adamant about this, and then they see it goes up and they freak out and they, toss their bookcase at you.
Yeah. Okay, yeah, there we go. This is going to be a fun class to philosophize with. Good point. Yes. So ultimately, if the world is perfectly defined, breadth-first search solves it, right? If it's totally deterministic and you know everything is going to happen, because it searches all possible cases. If something changes that doesn't affect the world, if there's no dependency, then you can ignore it. If there's a dependency but it's slight, then your answer is going to be slightly off. So it's not that we have to get all weird about it. You can use breadth-first search in the real world, but the accuracy of its optimality will be dependent on the accuracy of your assumption that you know what's going on and modeled it correctly, right? So to the extent that you have modeled the universe correctly, breadth-first search finds the optimal solution. Is that a good way to put it? Yeah.
How would you get around this problem of non-determinism? Because aren't computers deterministic by default? They can't really act necessarily.
Computers are deterministic. Okay, while we're on that topic, do you know the difference between a random number generator and a pseudo-random number generator? Computers implement pseudo-random number generators, and they usually call them random number generators. So to a computer scientist, they're the same thing. In reality, the term random number generator has a technical definition, and it means something that involves non-determinism. There's philosophical debates about whether random number generators even exist. People who believe the claims of quantum mechanics often claim that at the quantum level there is true non-determinism. But in my opinion, quantum mechanics is still on the fringes of scientific advancement, and so the claim that we know everything is pretty bold, right? I don't think we know everything about quantum mechanics. Therefore, is there any chance there's a hidden variable? Something we don't understand about what makes an electron appear at a certain position in its cloud. Of course, there's still a possibility. Therefore, there is no reason, as far as we know, as far as I know that we know, that to believe that non-determinism has ever been definitively discovered or determined. I don't think it's a thing. I think there are hidden variables all over in the universe. I believe in determinism. You don't have to, I don't care. I'm just trying to point out that this is a philosophical issue, and all it really means, whenever I say non-determinism, you can just think to your mind, something you don't know. And if you don't know everything, then you can't perfectly model everything, and if you can't perfectly model everything, then breadth first search struggles. With me? Okay, yeah.
Wait, how does breadth first search handle a deterministic but infinitely large universe?
This is when we run out of memory. That's this problem. And because you have a Turing machine, it's not a problem. Except you don't have a Turing machine, so it is. Breadth first search doesn't handle that problem. Here's what I'm trying to hint at. We're going to spend the rest of the semester solving some of these problems. We're going to learn how to make intelligent decisions without having a Turing machine, without having crazy amounts of memory. We're going to try to figure out how to handle moving goals or goals involving other players. We're going to even try to handle noise or non-determinism, which to me just means noise, because what's noise? That's when there's another variable adding to the mess.